July 23, 1983. Air Canada's newly entered Boeing 767 is on its routine flight from Montreal to Edmonton. The flight crew has less than 100 hours of flying experience on this aircraft type. Cruising at 41,000 feet, a warning of low fuel pressure suddenly appears from the left engine and then followed by the right engine. Computer says there should be enough fuel in the system, but fuel gauges are not functioning. Both engines flame out completely. The plane has lost all its power. This 132-ton powerless glider starts to sink at a rate of over 2,000 feet per minute over the vast Canadian plains with marginally enough hydraulic pressure to control its surfaces. Will the 69 passengers on board safely touch down? Or will this become an indelible chapter in Canadian aviation history? What happens when a giant Boeing 767 runs out of fuel at 41,000 feet? This is the unbelievable but true story of Air Canada Flight 143, known ever since as the Gimli Glider. In September 1982, the first Boeing 767 entered service with United Airlines. The 767 was Boeing's first wide-body twin-engine jet, and its first one to feature a two-crew cockpit, eliminating the flight engineer. Air Canada ordered 12 two-crew Boeing 767s with deliveries scheduled for 1983 and 1984. By July 1983, 4 of these aircraft were in service, including the one we are going to talk about today, also known as the Gimli Glider. On the evening of July 22, 1983, this 767 faced an unexpected issue upon arriving in Edmonton, Alberta. The routine maintenance check conducted during its stopover revealed that the fuel gauges in the cockpit were blank, despite the aircraft's power being on. This was a critical matter as the fuel gauges play a pivotal role in monitoring the fuel levels in different tanks of the aircraft. The information from sensors in the fuel tanks is processed and transmitted to the gauges via 2 redundant data channels, designated Channel 1 and Channel 2, either of which is capable of supplying the data by itself should the other fail. Konrad Yaremko, the technician in Edmonton, diagnosed a fault in Channel 2 of the fuel quantity processor, using the system's built-in test equipment, although he managed to temporarily resolve the problem by pulling the circuit breakers for both channels, then resetting the breaker for Channel 1 only. With the faulty Channel 2 now offline, the data passed through Channel 1 without any problems, and the gauges blinked back to life. He recommended replacing the faulty processor. However, due to the unavailability of a replacement, Yaremko followed protocol and logged the issue. Now the aircraft was allowed to continue flying with one processor channel inoperative, provided the fuel gauges were functional and a manual check of fuel levels was performed as it was listed in the Minimum Equipment List, or the MEL. The MEL is a list that specifies the minimum equipment an aircraft is allowed to operate with, ensuring safety and compliance with regulations, even if some components are temporarily non-functional or removed. The next morning, when the new flight crew, led by Captain John Weir, arrived, Yaremko was still on duty. Yaremko briefed Weir about the problem, but a misunderstanding occurred. Weir got the impression that the plane had been flying with the issue since it left Toronto the day before. In truth, the fuel gauge problem only became known on the ground after the plane landed in Edmonton. The following day, Captain John Weir and his crew took over the aircraft in Edmonton, unaware of the recent ground issue. They successfully flew to Ottawa and then Montreal without encountering any problems. At each stop, the pilots and ground engineers worked together to perform a manual fuel drip test to double-check the amount of fuel in the tanks, and each time no discrepancies were observed. Weir's shift ended at Montreal's Dorval International Airport, and together with his first officer, he walked out to the parking lot, where he met the incoming Captain Robert Bob Pearson, who was to take over flying the 767 for the rest of the afternoon. It was during this conversation in the parking lot that a second misunderstanding occurred. Pearson got the same impression that the fuel gauge issue had persisted since the plane left Toronto on the previous day, leading to a misinterpretation of the situation. Weir said they needed to do a manual drip test to check how much fuel was in the airplane. Pearson thought this was the only way Weir knew the fuel amount. So, Pearson expected to see empty fuel gauges when he got on the plane because he thought that was the only method Weir used to figure out the fuel level. Meanwhile, ground engineer Jean Ouellet, assigned to perform a fuel drip test before the next departure, suspected more issues than initially diagnosed by Yaremko. In an attempt to verify Yaremko's diagnosis, Ouellet reset the circuit breakers, causing the fuel gauges to go blank again. Hence, Yaremko's diagnosis was confirmed, but before he could get any farther, he was called back out of the aircraft to help perform the drip check, in the process forgetting to return the circuit breakers to their original positions. When Captain Pearson and his first officer Maurice Quintal arrived in the cockpit minutes later, they found the fuel gauges blank, which was, coincidentally, exactly what they had expected. Captain Pearson, upon reviewing the logbook, misinterpreted the MEL entry, believing it allowed the plane to fly with all fuel gauges blank. This contradiction puzzled the crew, and they began to conduct a manual fuel check using drip sticks. Drip stick test requires sticks in the fuel tanks to be measured, indicating depth in centimeters. The depth is then converted to liters using a table. Then, further converted liters to weight of fuel for the pilots, who cared more about the fuel's weight than its volume. Now, the Air Canada 767s had a unique fuel measurement system compared to the rest of the fleet. While other planes used various units, the 767s were equipped with metric fuel gauges. This was in line with Canada's transition to metric units, driven by the government, which owned Air Canada. However, apart from the fuel system, most measurements in aviation, like altitude and speed, still use traditional units like feet and knots. The shift to metric for the 767s reflected international standards for aircraft weight and fuel quantity. Under normal circumstances, the flight computer automatically handles the conversion from liters to kilograms or pounds, and vice versa. Manual calculations, like during a fuel drip check, are rare and only occur if there's an issue with the fuel quantity system. At Air Canada, neither flight crews nor ground engineers were trained for these calculations, and it was unclear who was responsible. Despite this, the first part of the drip check went smoothly. After extracting sticks, measurements of 64 centimeters and 62 centimeters were taken for the left and right wing tanks. The center tank was empty, typical for domestic flights. Ground engineers Jean Ouellet and Rodrigue Bourbeau consulted the conversion table, determining figures for the two tanks, totaling 7,682 liters of fuel on board. Now they needed to convert the 7,682 liters of fuel into kilograms for the upcoming flight to Ottawa and Edmonton. Captain Pearson aimed to uplift enough fuel for the entire trip to Edmonton, estimating he needed 22,300 kilograms. To determine the amount to request from the fuelers, he had to subtract the fuel already in the tanks from the total. The team asked the fueler for the conversion factor, and he provided 1.77. However, there was a crucial misunderstanding. The fueler assumed Air Canada planes measured fuel quantity in pounds, and he had not been told that only the 767s measured fuel in kilograms. Neither the pilots nor the ground engineers were aware of this, assuming the fueler meant 1 liter of fuel weighed 1.77 kilograms when it actually weighed 1.77 pounds. Despite the logical discrepancy, no one caught the error, and the proper conversion factor of approximately 0.8 was overlooked. Thinking they had the correct conversion factor, ground engineer Bourbeau attempted to multiply 7,682 by 1.77 for the fuel calculation. However, the team mistakenly arrived at 13,597 kilograms of fuel, believing this was the weight. Captain Pearson, using a mechanical calculator, confirmed their math, but missed the unit error. The fuel was in pounds, not kilograms. Unaware of the mistake, Pearson subtracted 13,597 from 22,300, calculating an additional 8,703 kilograms of fuel needed for the trip to Edmonton. To communicate this to the fueler in liters, they incorrectly used the same conversion factor, dividing 8,703 by 1.77. This resulted in 4,916 liters, which the fueler rounded up to 5,000 liters and pumped into the tanks as requested. The numbers were meaningless because they resulted from subtracting pounds from kilograms, which is not valid. A pound is slightly less than half a kilogram. Consequently, the initial fuel load was about half of their calculated amount. This led to an incorrect additional fuel requirement, compounded by dividing it by the wrong conversion factor. The fueler added less than a quarter of the required fuel. They actually needed about 20,000 additional liters, not 5,000. After accounting for the existing fuel, they had a total of 10,146 kilograms, which interestingly equates to 22,300 pounds, the right amount of fuel, but in the wrong units. This discrepancy would have been obvious if the fuel gauges were working, but they were not. And while the MEL clearly stated that departure without working fuel gauges was prohibited, nobody seemed to be acknowledging this fact. Pearson believed the plane had been flying without fuel gauges since the previous day, assuming someone with more authority had approved it. By the time all was said and done, Air Canada Flight 143 pushed back from the gate. On July 23rd, Captain Bob Pearson and First Officer Maurice Quintal were piloting Flight 143 on a routine flight from Montreal to Edmonton via Ottawa. Captain Bob Pearson, aged 48, had been with Air Canada for about 15 years and had logged over 15,000 flight hours, while First Officer Maurice Quintal, 36, had been flying since he was 16, followed by service in the Canadian Air Force, having logged over 7,000 hours of total flight time. The plane reached Ottawa. Some passengers disembarked, others boarded, and the crew also conducted another fuel drip check as was required. Unfortunately, the measurement was still incorrect for the same reasons as before. The crew did the math again, using the wrong numbers, and thought they had enough fuel, even though the total was actually completely wrong. At last, the 767, now with 61 passengers and 8 crew aboard, Flight 143 left Ottawa, bound for Edmonton. Flight 143 climbed to its cruising altitude of 41,000 feet and cruised normally above Ontario and into Manitoba. The first hour of flight was straightforward for the experienced flight crew. Just after 2000 local time, the crew and passengers had just finished dinner. Cruising at 469 knots over Red Lake, Ontario, conversing with an Air Canada engineer about the systems on the new 767, Pearson and Quintal were shocked to see cockpit instruments warning of low fuel pressure in the left fuel pump. The 767's engine indicator and crew alerting system beeped 4 times in quick succession, alerting them to a fuel pressure problem. Once the warning came on, however, the reason must have been self-evident. Given their inoperative fuel gauges and the difficulties calculating the fuel load, the most sensible cause for the warning was a lack of fuel. This was confirmed moments later when the independent right-hand fuel pump also produced a low fuel pressure warning. Recognizing that he was facing a serious emergency, Captain Pearson immediately decided to divert to the nearest major airport. In this part of the country, that could only be Winnipeg. Other options were decidedly limited, given that the terrain underneath the plane consisted of empty Canadian Shield, followed by the mighty expanse of Lake Winnipeg, neither of which offered much in the way of airports or runways. With that in mind, the pilots apprised air traffic control of their intent to divert to Winnipeg, secured permission to turn south toward the airport, and began a relatively sedate descent from 41,000 feet. Unfortunately, the illusion of control didn't last long. The pilots had barely begun the diversion when the left engine, starved of fuel, abruptly flamed out. Shortly thereafter, at 2021, when their altitude was 28,500 feet, and they were 65 miles from Winnipeg, the right engine followed suit. Circumstances then began to build fairly rapidly. The ACOS issued a sharp bong, indicating the complete and total loss of both engines. Things got quiet, real quiet. Starved of fuel, both Pratt and Whitney engines had flamed out. Just 5 minutes after the first sign of trouble, Captain Pearson and First Officer Quintal faced a highly unusual emergency. In 1983, there were no established steps for flying and landing without any engines. The $40 million Flight 143 was gliding. To make matters worse, the low fuel levels led to a significant loss of electrical power, which blanked out most of the pilot's instruments. All that remained were a few basic analog backups, a standby attitude indicator, an altimeter, an airspeed indicator, and a magnetic compass. The situation could have been much worse if it weren't for the ram air turbine, or RAT. This small propeller automatically deploys below the plane in the event of a dual engine failure, generating power to keep the hydraulic pumps running. The RAT can supply just enough hydraulic pressure to move the control surfaces and enable a dead stick landing. Without the RAT, the pilots wouldn't be able to control the 767's large control surfaces. An airliner without engine power will descend at a fairly controllable rate all on its own. The much more difficult part is nailing the landing. Gliding a jet down to a powerless or dead stick landing requires a great deal of precision, since only one approach can be attempted. And a continuous descent must be made all the way to the runway with no possibility of leveling off. Circling to land is also difficult, if not impossible, because making tight turns without engine power can easily lead to a stall. As far as they knew, the crew had two options. Winnipeg, 65 miles away, offered long, well-kept runways and full emergency services. On the other hand, there was a decommissioned military airbase in Gimli, around 45 miles from their current position near Lake Winnipeg. First Officer Quintal, who had previously served in the Royal Canadian Air Force, suggested Gimli as a potential landing site. However, the base's current condition was uncertain. It had two 7,200-foot runways, shorter than those in Winnipeg, with no guarantee of maintenance and no known emergency services according to air traffic control. The only advantage was its proximity. The crucial question was whether distance would be the limiting factor. The crew had only a few minutes to choose between the two airports before committing to a landing. The crew faced a new challenge as they had no direct indication of their descent rate. The vertical speed indicator, along with most other instruments, had stopped working. There was nothing in the manual about the minimum sink. Boeing never expected anyone to try and glide one of their jet airliners. The windmilling engine fans were creating enormous drag, giving the 767 a sink rate of somewhere between 2,000 and 2,500 feet per minute. First Officer Quintal had to manually calculate their descent angle using altitude and the distance from Winnipeg at regular intervals. The 767 had lost 5,000 feet of altitude over the prior 10 nautical miles, giving a glide ratio of approximately 11-to-1. The 767 was sinking too fast. They were 33 miles from Winnipeg and 12 miles from Gimli. According to his estimate, they could only glide another 20 miles, maybe less. At 20:31, the pilots quickly made the decision and informed ATC. Flight 143 is diverting to Gimli. Meanwhile, in the cabin, the 61 passengers scattered throughout the mostly empty 767 prepared for the worst. Having at first been told that they were diverting to Winnipeg because of a technical problem, the passengers realized the true seriousness of the situation only when both engines suddenly rolled back, leaving the cabin eerily silent. Convinced that they were going to crash into Lake Winnipeg, some passengers began writing wills or notes to loved ones on any scrap of paper they could find. The flight attendants did their best to prepare the cabin, instructing passengers on emergency procedures, although they themselves had no idea what to expect. Back in the cockpit, the pilots made their final adjustments for the imminent emergency landing. After completing a sweeping turn to the right, Gimli Air Base hove into view. Notably, the RAT didn't power non-essential controls such as the flaps and slats, which increase lift and enable low-speed flight. So Pearson knew they would have to come in hot. What he did not expect was that the RAT didn't provide power to the landing gear actuators either. Moments from landing, Quintal attempted to lower the landing gear, but when he pulled the gear lever, nothing happened. Thinking quickly, he reached for the alternate gear extension switches, which bypass the hydraulic system to lower the landing gear in freefall, also known as a gravity drop. Upon flipping the switches, they heard the main gear fall and lock in place, but Quintal only got 2 green lights, not 3. The nose gear, which fell forward against the wind, hadn't gone over center. As the aircraft descended without power, Pearson needed all his flying skills to keep it on track. He had only one chance to land. There could be no missed approach. At around this time, Captain Pearson began to realize that they were coming in too high. If he didn't lose altitude fast, They would overshoot the airport entirely, but if he put the plane into a steep descent, it would gain too much speed and they wouldn't be able to stop on the relatively short runway. They needed some way to bleed off their excess height without increasing their speed. One way to do this would be to make a 360-degree loop, but Quintal could tell at a glance that with their current descent rate, it was already too late to complete one. They would strike the ground before making it back to the runway. Besides being an airplane pilot, he also flew gliders for fun. He knew how to control planes without engines, and one useful move he knew was called a forward slip. A forward slip involves lowering one wing and using opposite rudder to keep the aircraft's nose pointed in the desired direction. This technique increases drag and steepens the descent without increasing airspeed. This was exactly what Pearson needed, informing Quintal that he was going to slip it. Pearson crossed his controls, steering hard right with the rudder and hard left with the ailerons. The nose swung out to the right and the wings banked sharply to the left, sending the plane into a terrifying forward slip. Passengers seated on the left side of the aircraft stared directly at the ground as, per Quintal's recollection, Pearson held the plane at a bank angle considerably in excess of 45 degrees. The gear on each wing was deployed, but the nose wheel was stuck part way. And it was only now, seconds before touchdown, that they suddenly looked up and realized that they had much bigger problems than a faulty nose gear. In fact, their runway was no longer a runway at all. The pilots were shocked to see people on the runway as they descended. Unknown to them and the controllers in Winnipeg, runway 32 left of Gimli's twin 6,800-foot runways had become inactive and was now used for auto racing. A steel guardrail had been installed down most of the southeastern portion of 32L, dividing it into a two-lane drag strip. The rally spectators were startled to see a huge aircraft bearing down on them, silent except for the rushing of wind against its body. But there was no turning back now. Pearson had no choice but to put the plane on the ground and hope the people got out of the way. At the very last moment, Pearson pulled out of the slip and planted the wheels on the runway, landing perfectly inside the touchdown zone, traveling at a speed of over 300 kilometers per hour. He immediately lowered the nose and slammed on the brakes, only for the partially extended nose gear to collapse backward into its wheel. Well, he had no choice but to slam on the brakes because right in front of him were two young boys on BMX bikes. They were on a drag strip and suddenly realized a huge Boeing 767 was heading straight for them. Instead of moving aside, the boys tried to race the plane. This made the pilot, Captain Pearson, brake even harder to avoid hitting them. Tires on the right main gear blew out and the aircraft skidded down the runway 4,000 feet on its nose and the right engine nacelle, stopping just 500 feet from amazed sports car racers and their families. With a big jolt and a lot of scraping sounds, the plane finally stopped, balancing on the center divider with its nose on the ground. It was unbelievable. Everyone on the plane, including the pilots and passengers, was safe. Flight 143 had somehow landed without hurting anyone, against all the odds, and the 767 was relatively undamaged. A small fire was smoldering under the cockpit, where sparks had set insulation material on fire. The tricky part was when the flight attendants tried to open the emergency exits at the back. The tail of the plane was so high up that the evacuation slides didn't reach the ground. Instead, it was more like jumping off the second or third floor of a building. Because of this, many passengers chose to use the exits over the wings, even though the slides there were not deployed. The flight attendants didn't know where they were supposed to be, as this incident happened before they received thorough training on this type of plane. The time was 20:38. Just 17 minutes had elapsed since Pearson had started flying a powerless 767 from 41,000 feet to a safe landing. Pearson and Quintal became overnight celebrities, and Gimli, a household name across the world. This Air Canada aircraft was repaired sufficiently to be flown out of Gimli just 2 days later. After approximately $1 million in repairs, consisting primarily of nose gear replacement, skin repairs, and replacement of a wiring harness, it re-entered the Air Canada fleet and flew for another 25 years. To this day, this aircraft is still known to insiders as the Gimli Glider. The Gimli accident led to a huge investigation by both the Canadian Transport Safety Board and the Federal Government Public Board of Inquiry. Air Canada's own investigation blamed the pilots and mechanics for the accident. The official investigations cast the net wider and concluded that Air Canada's procedures were at fault for not reassigning the responsibility for calculating the fuel load when use of a flight engineer became unnecessary with the new Boeing 767, which was designed to be flown by a two-pilot crew. It also confirmed that the recent change from the imperial measurement system to metric resulted in a series of miscalculations as to how much fuel was actually aboard the aircraft before the flight. It all stemmed from a chain of events, neutralizing safety nets, involving fuel gauge errors, dispatch contraventions, and miscalculations. Anyhow, the mishap underscored broader issues, including the introduction of metric aircraft into a non-metric fleet and the need for standardization and clear communication protocols in the aviation industry. Quick fun fact before we end this video: during the 30th anniversary of the Gimli Glider incident, Captain Bob Pearson crossed paths with Pearl Dion, one of the over 61 passengers on board, during that fateful landing. Both Pearson's wife and Dion's husband Rick had died years earlier. Little did they know, this chance meeting would lead to a decade-long love story, and now have been enjoying their life together for past 10 years. Thank you so much for making till the end. Consider subscribing to stay in the loop for our upcoming uploads. We'll see you next time.